All right, for this video lesson, we're going to be doing topic 6.2, determining if two polygons are similar. Okay, so we're continuing with chapter 6. So reminder, figures are similar if corresponding angles are equal and corresponding sides are proportional. So remember, corresponding angles are those that are in the same relative position, same with sides in the same kind of spot. If we know corresponding sides are proportional, we do not need to check the angles. However, if corresponding angles are equal, we still need to check that the sides are either enlarged or reduced by the same scale factor. Okay, so as we go through these problems, make sure we are showing all of our work as always. Okay, so question, and this topic is like determining if polygons are similar. So usually it's just like you're proving this, okay? So here, this angle right here, okay, that indicates that these angles are the same. Same with the check marks and the X's, okay? So those angles are all equal or congruent, okay? So now we just got to make sure that those sides are enlarged, reduced in this case by the same scale factor, okay? So remember the formula for scale factor is model over actual or new over old, okay? And again, whether it's new or old, it's kind of arbitrary, okay? So just assign one as the other. I'm going to call this one new, and this is going to be my old one, okay? So let's just do one side at a time. So let's start with this 6, okay? So scale factor is equal to new divided by old. So 6 centimeters divided by 3 centimeters, okay? That gives me a scale factor of 2. Okay, so next we just need to check that the bottom is enlarged by the same scale factor as well. Okay, so scale factor is equal to new over old, which is 5 centimeters divided by 2.5 centimeters. Okay, punch that into your calculator. You get a scale factor equaling 2. Therefore, they are similar. Okay, so you just need to show your work and prove that they are similar. Okay, so Pierre drew 2 regular hexagons. Okay, so the question is, are they similar? Why or why not? So remember, a regular hexagon or a regular polygon in general are those that have all equal sides and all equal angles. Okay, so even if I were to just pick a hexagon right here, okay, and I just drew that. There's a regular hexagon of one particular size. Now, if I make one that is almost twice as big, okay, all angles are going to be the same size, but the side lengths are going to be enlarged by a factor of 2, okay? Because the scale factor is the same and all angles are going to be equal, we say that they are going to be similar hexagons, okay? So any 2 regular polygons, whatever the shape is, will be similar. Okay, so next question. So Zora says that the 2 rectangles below are not similar because 60 divided by 50 does not equal 100 divided by 30. So is Zora right? So first, we have to make sure that we are dealing with corresponding sides, okay? So note that these 2 rectangles are not on the same length, right? This triangle right, or this rectangle right here, excuse me, is on its longer side, and the rectangle to the right is on its shorter side, okay? So let's make sure we're going to compare the same sides on each one. So let's take the long side over here and compare it to the long side over here, okay? So hopefully you're saying, Jones, that's a scale factor of 2. Okay, you're right. Just let me show you. Okay, so this will be my new. This will be my old over here. The scale factor is new over old. So my new image is 100 centimeters. My old image was 50 centimeters. Gives me a scale factor of 2. Okay. Now let's just check that the shorter side length to make sure that it is enlarged by the same scale factor. So scale factor is equal to 60 centimeters divided by 30 centimeters, which also gives us a scale factor of 2. Okay. So Zora is incorrect. Okay. Because the Zora was comparing sides that were not corresponding. Once we were able to identify the corresponding sides, we were able to see that it is increased by the same scale factor. Therefore, these triangles are similar, or rectangles. And pardon me for keep saying triangles. That will be our next lesson. Okay, so let's keep rolling here. So determine if the two given parallelograms are similar. Okay, so again, we're given an angle and 2 side lengths. So with the angle, we can just kind of leave that alone, and we just need to deal with the side lengths. Okay, so let's pick one pair of sides to make sure that they are corresponding, and let's check what the scale factor is. Okay, so let's call this one the new. And this is the old. And remember, what we say is the new or the old is kind of arbitrary. It doesn't matter as long as we're consistent, okay? So scale factor formula is new divided by old. Okay, we're comparing the 12-inch side and the 8-inch side. Okay, we punch that into a calculator and we get a scale factor equaling 1.5. Okay, let's do the same thing with our base to see if we have the same scale factor. Okay, so the new one is 8 inches divided by 6 inches was my old scale factor. Punch that into our calculator and we get a number of 1.3 repeating. Okay, so because we do not have the same scale factor, therefore, parallelograms, well, these parallelograms are not similar. All right. So that's it for this lesson. So it's kind of an extension of 6.1. So just making sure you're able to calculate that scale factor and see if all sides are either increased or reduced by the same scale factor. You should be in good shape for this assignment. So if you have any questions, please reach out. And if not, please go ahead and start working on topic 6.2 practice problems. Thank you. Have a good day.